Hello everyone, it's January the 8th. I spent the entire day today learning something called Dash. It's a Python-based library that allows you to do dashboard. I used to spend a lot of time doing another one called Streamlit. But back then, I think maybe a year or 2 years ago, Streamlit was very limited in terms of what you can do on the JavaScript side of things. Like I think I can hover over it and I can see the things, but I cannot trigger things just by hovering my mouse on top of a data point. Now that I don't know, maybe Streamlit you can do that now. I mean it's possible, but I just from just browsing through Stack Overflow, somebody asked a question about Dash and I never heard of it, so I took a look. Man, that library was quite powerful. It's actually very powerful. I went through the tutorial and I didn't went through the whole thing. There are 5 parts. I went through 4 parts, get a basic understanding of it. It's nothing to do with the question being asked, but I consider this not time wasted because I do need to build a dashboard sometime in the future, and I think it is extremely important that we kind of make things right now, change things right now. So to learn this new way of doing dashboard, it could be very useful in the future. All right, anyway, so yeah, that's basically what I did today. Didn't do anything else, didn't read, didn't do anything else. And it's already 10:38. I want to go to bed a little bit earlier because I just bought a program for squat from Seek of Strength. Man, I think it's a 3-hour workout for me today. Very tiring. So I want to sleep early. And tomorrow definitely no squat. I think I will power everything. I have to practice on the technique no matter what, but no squat tomorrow. Maybe I'll do a little bit full range on Tuesday, and on Wednesday it's another squat session. There's only 2 squat sessions a week, but dude, today is like 4 sets of 10. Man, I haven't done sets of 10 in I don't know how long, so it's quite challenging. It's a shock, definitely a shock to my leg. I don't feel anything right now, but I'm pretty sure tomorrow will feel something. And I think I kind of messed up with my ankle a little bit because we have like in the program there's a piston squat negative, and I think I landed on my right side. I wasn't able to control it as well as the left side, so I kind of hurt my ankle. Anyway, today is very simple, binary tree. So we'll try. I think I'll do half an hour, then I'll cut it. All right, I don't even have to read the problem. It's just a regular traversal. Whatever traversal they want to do, I'll do it. It does not matter. Does not matter. What do we want to do? Pre-order. I don't even know what's pre-order. A root left right. Is that pre-order? Oh, 1. That doesn't say anything. Why? Why would I do it iteratively? It's useless. I'm actually not sure. What's a pre-order? I think it's a root left right, but not 100% sure. Let's get a full tree. 5, 6, 7. Okay. So I go say if it's root left right, it should be 1. Let's see. What's the 1? 1, 2, 4, 5, 3, 6, 7. Yeah, it's a root left right. All right, let's take the challenge. Do it iteratively. Well, it's the same. We just need a stack, right? I actually never done it before. Dude, we need a stack in the result. And oof. So we push into the stack. Oh, actually, I don't know how to do so. We push into the stack, we pop the stack out, push a new thing into it. Is that what it is? Hold on. Yeah, this is actually interesting. Maybe it's a while stack. Node equals stack dot pop, and then rest dot append node dot value, the value. Node dot val. Okay, and then we say stack dot append node dot left, stack dot append node dot right, and if node, right? And then blah blah blah, or return rest. Interesting. Never done it. That's the first time. Ooh. I can't do left and right. So if I push left and I push right, then the thing pop out is right. So I have to push right first. Huh. Interesting. We have to push right first. Very interesting. Have to push right first. Did I also do it last time? I'm not sure. I probably do a BF. No. Nope. That's just another way of doing it. Yeah, that's the way. Oh. So, oh, slightly better. Oh, yeah. Because I'm gonna pop. So, is it gonna be a Q? The way I'm doing it is actually a Q, right? Root left, right. And the left. Oh, but in the actual thing, when you do left, you call left again. So you just keep pumping. Here is different. We push right in, then push left. So the first pop is left. And I push more right in first. So the left always pop out of the first. Iterative. Full 4. Okay, so that's that. Done with this. Yep, right first. Gotcha. All right, let's do this. We have a solution. Oh my god, I forgot. We'll go 3 to the end, and then we will only record the one that contains. How do we do this? Oh, we can say true or false, the path. And then when it hit the end, then when it hit the end, and we return that, and then we change it, and then we do this. Okay, yeah. I remember. So I think the best outcome today will be, we got this done. Edges. I cannot use edges because edges I is AIBI. Yeah, so I have to go with a graph. but n minus 1. Edge's length is n minus 1. Amount the length. What's amount? Okay. So what we can do, n equals line amount. So graph is going to be for this in range n, this, right? And for a, b in edges, graph a dot append b, graph b dot append a. Okay. Now have def dfs. Index path, right? That's gonna be the list of this. And eventually, what's the eventual? Contains Bob. No, not contains Bob. Once it hits 0, okay? Once it hits 0, don't return anything. So all we need to do is find the path that goes from Bob to 0. So self dot Bob path. Okay, Bob path is nothing. And then we say path, go to the next one, and everyone we added, so go to the next one. Then we say if index is equal to 0, okay, then self dot bob path equals path plus 0. Done. And return true. Okay, let's go boolean. Okay, otherwise a path dot append index. I can do this. Yeah, let's do this. Path dot append and I don't like it. I do not like it. I like to put it here. Path dot append, and then for next in graph index, if next is not equal to parent, I need to pass a parent. Okay, next is not equal to parent, dfs next parent is the current and the path. Oh, actually I don't care, right? I just return true. I don't care. I do not care. I honestly do not care. So I can just append it at the beginning, right? Because if it's true, then don't care. We append at the beginning, and this just equal to, we can equal to path, because we do not care. All right. And then we say if this is true, we return true. Right? Otherwise, we try the next one, try the next one, try the next one. Once all tries, no true, path dot pop, and I'll return false. Okay. So now we can say DFS. We start with Bob. Parent is -1. Path is this. Okay. Yeah, I actually want to try. See if this one works. Not very confident. Oh, then we have we need to write 2 DFS. Is that so? Is that so? We do need 2 DFS. Because this one, if we can just do 1 DFS. No, I have to do DFS. So this is DFS Bob. Call Bob DFS. Okay, so I'm gonna say Bob DFS. Start with Bob and then do this. I need something here just to make sure everything is performing well. We have this -7280, right? -7280. Okay, perfect. Then we need to do this. Cancel all of them. Here we have edges, Bob, amount, most profitable path, edges, Bob. Okay, I just want the first one. And all I want is to see self.bob path. DFS is not defined. Oh, of course, it's Bob DFS. 310. 310. That is true. Okay. So now we get a Bob path. And they're coming, right? So if they're coming, we need to know which one, if they do meet each other. Oh, but just be careful, all right? Be careful. Like they meet each other, that's when. So we know Bob goes directly. I mean, maybe there are two paths. No, that's not possible. To reach each one is only one path. So all we need to do is going from both sides, moving in, and whatever they meet in the middle, that one is going to be. What if it's even numbers? Well, it's even number pa, and then there will be nothing, right? So we say if len self.bob path is odd, then self.bob path. Actually, I don't even need self.. I just say bob path. That's fine. Right? We just say bob path len bob path divided by 2, like 3 divided by 2. This one, and now we need to know. We can say I equals. Right, I equals this, and then this is the 310. That's the 1, right? And then the 1, the value need to divide by half, which is amount. This divided equal to 2. Okay, and then we'll say the half. Right, let's say for I in range divided by 2, so it will be 1. So we don't take 1, so it's only 0. If it's even, like 4, it'll be 2, so 0, 1. Yeah, so we say amount bob path I, right, will be 0 because Bob already handled everything. Okay. So when that's done, now we can say def Alice, right? Is the other one's Alice, right? Alice DFS index, right? We need parent as well, but we don't need a path. All we need is the profit, right? All is the profit so far. And this one return nothing. We'll have to go through every single thing. What do we do? What we do is we need to know when we hit the end, which is for 1, is leaf will be false. No, leaf is true. Okay, his leaf is true. And then we say for next in graph index. Now profit need to first handle. So profit plus equal to index. Not index, amount index, right? And then if it's leaf, oh, we have a result. What a maximum. So we start, ooh, maximum net income or net income. It's not profit. That's net in. Okay, net in. So this has to be math dot minus infinity. And then for each one, we say if next is not equal to parent, then we say is leaf equals false, right? And then Alice DFS, we say next index net in, right? And then blah blah blah. Once we're done, we say if is leaf, then res equals maximum res and net in. Then we run, right? We run Alice DFS. Here goes 0. Parents minus 1. Net income start with 0. And we return a result at the end. Okay, let's see this one. None type has. Oh, bypass. I need to do this. Oh, hold up. Hold up. Hold up. Hold up. I think something is not right. Hold up. Let's see. Bob pass. Bob pass is empty. Alright. Copy it then. It was right earlier. Yo, man. What the hell? What the hell? It was correct. It was correct earlier. That's the only time Bob pass that shows up. What the hell? It doesn't make any sense, man. It does not make any sense. We have to do self dot? Wait. What the hell happened? It was working earlier. Huh? That was earlier, right? Yo. This is weird. How? I don't know, man. I have no clue. Oh, damn, I forgot this one should be printed afterwards. Oh, you dummy. Wait, so this one shall still work, right? Oh no, it's inside. That's why. Alright, so this one should be alright. We just need to add a little brain fart. Yeah. Okay. Once it's done, now we do this. We have a we have to go self.res. Same thing. Yep. Yep. All right, let's try this. Okay, give this a shot. Come on. Show me a good deal. A good deal it is. First, find Bob's path to root. If Bob and Alice are to meet, are only able to meet, if Bob's path has odd number of nodes, then the amount of the middle node must be halved. Furthermore, all the nodes that Bob has traversed before the middle node must have their amount zeroed out. Then we traverse Alice. All the paths to leaf, we use the updated amount to compute net income and return the max among them. ON. Just 2 of this is ON. Okay, so that's that. 2 DFS, 1 DFS, simple approach. 1 pass. Ooh, we can do 1 pass. I guess you can. Your 1 pass, you find Bob. When you find Bob, then what? You keep the path. Oh yeah. You can do 1 path. 1 path. Pass. 1 pass. Okay, so this is that. This is 1 pass. This and change. This is self.res minus math.infinite. We're actually gonna do it this way. Take this one here. Actually, nothing to do with Bob. We're just gonna make change to this. Okay. So basically we need a path. Actually, we don't even need to do this. We just need to add everything, right? Yeah, we don't even need this. We just need path. This is not necessary. Path.append index. Okay. If leaf is true, blah blah blah. This self.res shall equal to maximum this and sum for I in path amount I. Then we do this. Okay, all we need to do is if index is equal to Bob, right? Then we have a path. Then we do this thing. let's say this is not self.bar path. This is just path. If path is this, all right, we know what we're doing, so I can just put in here, save this, and then everything will save to this. Right? Okay, solution 2, let's see if it works. Net in, no, we don't have net in, we don't have path. And then would be this. At the end, path.pop, don't forget. And then we just don't call it Alice, we just call it DFS. Okay, we have some issues. Why? Oh, I know, because I have to go with the back to the front. Land path -1. 2. Oh, easier. -I. Oh, I can do it that way. Okay, so we'll have to do length path -1. 2. So this. Right, if 3 minus 2 is 1, right? And if we say, oh, I hate this. Hold on. This 5 over 2 is 2, so I cannot hit this. But now I cannot hit. Oh, that is still right. I just cannot hit this one. All right. And if it's this, that's 2. 3. Oh, so we have to go 3 divided by 2 is 1. Okay. So 5 minus 4 divided by 2. So it should be length path -1 divided by 2, and then we do -1. All those become 0. Now we do 1 pass. Same, everything is the same. Oof. Oof, how? How is that possible? Oh, I see how is that possible. Because after this, we have to return. We have to get the price all back. Ah, I can only do it at the end. Yeah, because I do this, then if I go to another one, then I see what happened. Okay. Okay. Okay, I can either give it back or I What would be the faster way? If Bob is in the path, then go through everything to find Bob, and then we go halfway. I can pass another thing. Okay, I like the other idea. I like this idea. Don't change it. Do not change it. We just pass one more thing. Oh, why pass? Oh, I do have to pass because I might have to change. Is Bob in? False. Right, and then we say is Bob in? It's true. Then blah blah blah, and then we say is Bob in? Okay, then we say if is Bob in? If Bob is in, then what do? We will go to Bob. So we say j equals path.index Bob, right? And then when we find it, then we do we do this first, right? And then we do this, and then we do this, do this, and then if Bob's in, we find a j. We say if j plus 1, right, then s shall minus equal to amount, this shall be j plus 1, right? That's j plus 1 divided by 2 divided by 2. Right, we remove half, and for I in range from, this is actually from j all the way to the halfway point. So it's j plus 1, right? That's j plus 1 minus 1, so it's j divided by 2. So for all of them, s minus equal to the entire thing. And then we do this. Okay, try it. A float is not iterable. Max and s. Okay. Let's see. I think this is a better solution. Let's see. Oh wait, it's the same. We got the same result. Huh? We got a path, right? And then we say if Bob is in. Yeah, Bob is in the path. Oh, not only Bob has to be in. But hold on, so we start with 0, right? And then we go down. There's only one route that can go to Bob. not a second way to go to Bob. Or are they? No, you can't. Why is this not right? Huh? I don't understand. What did I do wrong? Okay, 0, 29, 30, 31. It's the same, right? 29, 30, 31. Yeah, it's the same. Oh, I think I know. Even if Bob was not on the path, if from here I go get here, right, it's like this, and I go the other way, I shall still. So, I see. Then how am I supposed to do it in one pass? No, it should be only one pass from 0 to Bob. There's only one pass. There's only one pass. So when we hit the Bob, as you can see, there should be only one path. Doesn't matter if we print. Bob is at 31, right? That's 31. And then A will go this. Alice goes and Bob go this. So these both become 0. So all the ones that contain 30 should be 0. Ah. Then how do we do? And these paths happens before. Good question. Good question. I actually don't know. How do we do one pass? I mean, what we can do is DFS once, we collect all the paths, and then, but isn't that the same as two paths? And then we find which path is Bob's in. Does that count as one path? And then we don't have to do this. We can just say all paths. All right. Don't do this. If Bob is in, we do this. We don't do this. We just say amount. And amount equals 0. Don't do this. Of course, don't do this. And say paths dot append. Okay, so we do this, and then return, right? Maximum for path in paths, and then sum for I in path amount I. Something like this. Does this count as one pass? I mean, I did run DFS once. Not sure. Yeah, that's gonna be my one pass. Does this count? That's interesting. How is this not right? Oh, I see. Ah, screw me. I know why. I know why. This is not necessary. This is not necessary. Here is where we do it. Hmm. 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 What's 0, 1 pass? What? We calculated along the way. Distance 0. Distance from 0 to 1. Distance from... Oh, I have the distance. I just want to return the maximum. Wait, what does DFS compute? Maximum from... Pick out the biggest sum among the subpaths, okay? So from this to the end, the biggest sum. And then what? I pick out the biggest sum from this towards the end. And then we try to see where am I if at the middle point, if I am smaller than I am myself. If I'm bigger, then I don't do anything. So the DFS is from I to the end, right? From this one, the subtree, the maximum for everything. And then we also return like the difference, the distance between this to the, if it's larger, and distance to be 0. If it's elsewise, then just equal to n. So we want to calculate the distance between any node from node I. So 0 to node I to this. So as we go, we have node I, otherwise it's going to be n. Because it doesn't really matter if it's not an ancestor. Right? Hold on, I need to. Well, not really. This one's not really. I want to finish in 1 hour. I need half an hour. Now it's already 1 hour. dp index. Right, so this is distance. Distance to 0, right? Distance to root equals max path sum in the subtree rooted at index. All right, because it's always going to take the max, and then because the things we remove is the same thing. Okay, so index parent and then distance to 0. Distance from index to 0. db is distance from Bob, index to Bob. Okay, we don't need this. We don't need any of this. Then how do you know it's going to be a leaf? db is going to be larger than n plus 1, larger than equal to n, if index is not an ancestor of Bob. So we can say d0 is going to equal to 0 if index is equal to Bob, else is n. Right, and then so next that should be db, right? That shall be d0 plus 1 because we go down, so it's higher and higher, and this will return two things. So we return a tuple of int and int. Right? What's in a tuple? That shall return the distance between index and Bob. Now we say distance between index and Bob is set to larger or equal to n if index is a child. Index is a child of Bob. No, index is not an ancestor of Bob. Okay. So in the DFS, so there's going to give me the current max and from, oh, it's index, it's not from next. So db next, right? So in the update res, right? So db the next is from this to if it's a smaller, if it's whatever value it is. I have my db, I have my current distance. Now I want to, because I don't know, I want to update because I don't know. Right? So if the next one is found to be actually good, the children, all right, their distance towards B. So for me, I want to keep the minimum. That's why it says minimum. So db equals minimum and db next. So if the next one is an ancestor, so I become smaller as well. If the next one is not an ancestor, then I remain at n. Right? So we do all that. Right? We do all that. So basically, have all of those, so their relations to Bob. Right? If one of them is smaller, then I should pick that one. So we do all that. And if there's going to be a leaf, right? If it's going to be a leaf, so it's actually after all this, db distance to B. Unless, what if I am at distance to B? Oh, I don't even care. If it is a leaf, then amount index right? Then what? Oh, it doesn't make any sense. But what if I am at Bob? What do I do? I'm at Bob, so db will become 0. Right? db will become 0. That doesn't make any sense. I say if current is Bob, why do I return db plus 1? What is this db plus 1? It's your distance. Distance to root. Distance between index's ancestor, direct ancestor, parent, and Bob. So this is the current, okay? db is the distance from this. Know that the return value is the distance between index's ancestor to Bob. So if we said that, this is the current. Yeah, I do not need this. And so if res is equal to minus math.inf, then we will return res is just equal to this. It's a leaf, right? And then db is, yeah, this obtain index's distance to Bob from its children. Then db will become 0. And we say if d0 is equal to db, right, midpoint, then res shall minus equal to, this is the current max, minus equal to amount what? Amount index divided by 2, just midpoint, right? Then we say if d0 is smaller than db, right, smaller than db, so we are at this position. No, larger than db. Alice is in a node already visited by Bob. Then res minus equal to amount index. Oh, I haven't even added yet. Ooh, haven't even added yet. Now return res and db plus 1 because I am db. So I will return dfs 0 parent 0 0. Index. That's not right. The heck? That's actually db current. What happened? We go to the end. Doesn't make any sense, huh? If no has no child, then the biggest sum is 0. What the biggest sum? What is DFS? What do you return? If DFS is the subpath, yeah, that's from the next, right? Like this. That is a subpath. But why would you say it's gonna be 0? It doesn't make any sense. Because I added it here. Because I'm handling it here. Rest is the children. leaf node has subtree max equal to 0. So we first find a subtree max, right? After we find a subtree max, then we do this. That makes more sense now. All right, that'll be it. Much longer than I expected. I'll see you guys tomorrow.